Pseudo multivariable calculus. Historical discussion we are pursuing in pseudo multivariable calculus. Pseudo multivariable calculus, how we can start with a normal phenomenon and we can solve the problem. The big thing that we saw in the capacitor model, how to find energy model of a capacitor and then how to find power model of a capacitor that we have already seen. We started with the power computation, that is voltage into current is power. And then slowly, we found out that energy stored in capacitor is 1 by 2 CV square, or 1 by 2 into 1 by C into Q square, where voltage or Q is the any moment what is the charge or volt any moment what is the charge or voltage. Tackle any mathematical problem through simplest way, and time to time, then you come up to vector and calculus. Generally, people start thinking immediately into calculus. Immediately. Okay, then here dx will come and here dy will come and then integration. Okay, they don't understand what are they doing. Okay, in that sense, we are in a phase to calculate the surface area and volume of a sphere. Okay, surface area and volume of a sphere. And if through Cartesian coordinate system, we calculated surface area and volume of a sphere. Mind blowing, amazing. Okay, we will do it in a spherical coordinate system also. That is surface area and volume of a sphere. But we proceeded with a discussion, if someone remembers it, that how we can calculate area. The main aim of how to calculate surface area. Calculate the surface area vector. Calculate the surface area vector. This is surface area. At this moment, surface area vector is perpendicular to the surface. If this is the surface, then surface area vector is like this. If this is the surface, then surface area vector is like this, 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 like this. Surface area vector is perpendicular to the surface. How to calculate surface area vector? In order to do that, if I try to calculate surface area vector at any point here, consider consider there is xy plane. Consider this is xy plane. This is x-axis, this is y-axis, and this is z-axis. This is x-axis, this is y-axis, and this is z-axis. Now, in that sense, x-axis, y-axis, z-axis. This is xy plane, and this is z-axis. Now, I have to calculate area vector at any point here, that is P. What is coordinate of this point? That is x comma y comma z. Now this P point, I make a cut in xz plane. At P point, I make a cut in yz plane. Makes sense? Now, in that way, we got in xz plane, we got a circle. If I cut in xz plane, we get a circle. And if I cut in yz plane, we get again a circle. Okay, now what is area vector? Area vector, what is area? Area means area means length into width is area. I believe we have covered it extensively. How to calculate area vector? How to calculate area? What is the simplest area? Simplest area is a rectangle. Simplest area is rectangle where there is a width and there is height, there is length. Width into length is area of rectangle. If width is a line, it can be denoted by a vector, that is A, and length is a line that can be denoted by vector B, then it is B vector. A vector cross product of B vector also gives the area. Consider if there is a rectangle like this and this is origin, then this point is the end point of the rectangle, and this point is x1 y1, and this point along the length, this is x2 y2. This vector is x1I plus xy1j. This point is x2I plus y2j. Cross product of a vector and b vector, and then calculating its magnitude will give the exact area of a rectangle. And cross product of these two vectors, a vector xi plus yj and b vector x2 plus y2, x1 plus y1j, x2 plus y2j, cross product of these two vectors will be another vector that will be perpendicular to the surface. This is the vector direction. If this is the surface, then perpendicular is the vector direction. Okay, anyway, that is the story of direction. Calculate the magnitude, you'll get the area. Or any two vector, A vector and B vector, not necessarily they make 90-degree with each other. A vector and B vector, take cross product of these two vectors, you will get area of the underneath it, that is the parallelogram. Okay, that is the idea of calculating the surface, calculating the area. Surface area. Surface can be like this. Surface not necessarily it is a flat surface, but if it is a flat surface, then one side vector and another side vector cross product will give the area. Not required that they make 90-degree with each other. Luckily, if they make 90-degree with each other, then that is area of a rectangle, otherwise area of a parallelogram. If this is not flat and it is curved, okay, then how we calculate the surface area? If this is flat, then this and these two vectors are straight line. But if it happens to be a curve, then what will be the surface area? Surface area like this or like this. Consider this is, if this is a straight line, all right. If it is a curve, then if it is a curve, then still, then this side is a curve line, this side is a curve line, and this side is a curve line. This side is a curve line, and this side is a curve line. Two curve line, one curve line and one curve line. Represent this curve line. Earlier it was a straight line. Earlier it was a straight line. Now it is a curve line. Okay, it is a curve line. This curve and this curve. Two curve line are there. Okay, but as for the pseudo multivariate calculus, the topic of the discussion is pseudo. When we write a code through simple mathematics, we will go along it. We will not change it. That is the idea. The area of a rectangle is width into height. Simple. Then we proceeded width as a vector or w vector and height as a length vector, L vector, or a vector, B vector. A vector into B vector is the area. There is no into there in vector form. A vector cross B vector. Then we proceeded. A cross B vector, luckily it gives the area of parallelogram also. No problem. Okay, now if I am trying to calculate the area of a curved surface, then this vector, this is origin, then this vector earlier it was a straight line and this vector was a straight line. Now this vector become a curve line, and this vector also, this vector become a curve line, curve line, and this vector is a curve, up, this vector is a curve line. This vector is a curve line, and this vector is a curve line, and this is origin. Now, but as per the pseudo mathematics formula, I'm not going to change anything. Now, this was earlier. It was a straight line, A vector and B vector. Now, if it becomes a from a straight, if it becomes a curve, still it will be represented as A vector and B vector. Now A vector is and B vector. What is A vector? A vector is xi plus yj. What is B vector? That is again xi plus yj. If it is a straight line, then calculating xi plus yj cross xi plus yj, or x1i plus y1j cross x2i plus y2j will give me the area vector. But if it is a kind of a curve line, Then we have to do little twisting in the A vector and B vector. That is also called length vector. Now, we have seen for a curved line, if I take a straight line, then this straight line can be represented through vector also. This point is origin and this point is x comma y. Representation of a straight line through a vector is xi plus yj. But if I take a curved line, then curved line is a set of tangential vector, not a single vector. Now, in that sense, we have everywhere y by x, y by x, y by x are different. In that sense, y by x is variable in a curve vector. In that sense, I have to twist the xi plus yj into take out the x. Now it becomes I plus y by xj into x. Now this same vector xi plus yj is same as I plus y by xj bracket close into x. But since y by x comes into the picture, that is variable, now it will cover the length vector also. Now in that sense, a vector will be represented as I plus y by xj bracket close into x cross product with b vector that will be also represented as I plus y by xj into x, or the b vector can be represented as y I can take out, then it becomes x by yi plus j into y. Same. Or I plus x by yj into x, or x by yi plus, first is I plus y by xj into x, or x by yi plus j into y. Okay, these two are the vector A and B, and calculating the cross product will give the surface area vector. Now, if someone settle it down, one is I plus that to calculate the surface area vector for a 3D sphere. Okay, mind-blowing, amazing discussion it is. Okay, now in that sense, now calculating the surface area here, if I take surface area at any point P, and that is x comma y comma z, then if I cut it in xz plane and then I cut it in yz plane, if I cut in xz plane, then it will form a circle. If I cut in xz plane, if I cut in xz plane, it forms a circle. If I cut in yz plane, it forms a circle. But still, what is the area vector at any point P? In xz plane, if I cut, it is a curve there. And in yz plane, if I cut, it is a curve there. Now, yz plane curve, that will be represented as a vector, and xz plane curve, that will be represented as a vector, and then cross product of these two will give the surface area vector. What is the curve vector representation of a curve that falls in xz plane, and what is the representation of curve vector that falls in yz plane? Now, in that sense, if this falls in xz plane, what is equation of this curve? If it falls in xy plane, then it is I plus y by xj into x. If it falls in xz plane, then it will be I plus z by k into x. Makes sense? If no one is it is not satisfiable, then if I cut it any point P here in xz plane, that point is xi plus yj plus zk, the vector that passes in xi plus yj plus zk. That is same as I plus y by xj plus z by xk into x. If it is xz plane, y is not variable, y is constant. So y by x will be 0. If I change x, y will not change. In that sense, it becomes I plus z by xk into x. If I cut in yz plane, similarly, it will be zj plus z by y k into y. If I do cross product of these two, then it becomes minus z by xi minus z by yj plus k bracket close into x into y. Now z by x becomes dz by dx because division will become differentiation. Z by y will become dz by dy. Now into x and into y. Into, if I multiply with something x and y, then it will become integral calculus d of xy or dx dy. Or from the beginning if we take, then it becomes I plus dz by dx k bracket close dx cross product with j plus dz by dy k cross product uh, bracket close into dy. This is called area vector, but we cut it into xz plane and yz plane. What about if I cut this in any plane and then I cut in any plane? I take any two plane, not necessarily xz plane or yz plane. This was given as an assignment, that can we calculate area vector if I am cutting in any xz plane, any plane that is z and any. Okay, for that for that purpose we took for that purpose we took xy we took xy coordinate. For that purpose we took xy plane. Now if this is the sphere, okay, for that purpose we took xy plane, and this is the sphere that is standing on the xy plane. Now here if I cut it in any z or any plane and then again cut in z or any plane. Earlier, consider this is origin. This blue color is the origin. If this is the origin, then this is x-axis and this is y-axis. X-axis, y-axis. This is xy plane. Now first we cut in zx plane. Means if this is x-axis, then this is zx plane. If this is y-axis, then this is yz plane. First I cut in xz plane, then I cut in yz plane. Consider I cut along a line that is 45 degree from the x-axis. I call it alpha. If this is x-axis, I call it alpha axis. Make sense? This is x-axis from this 45 degree. I call it alpha axis. And then this is y-axis. This is x-axis. This is y-axis. From y-axis 45 degree again means from x-axis it will be 135 degree. 45 degree from y-axis I call it beta axis. Alpha axis that is 45 degree from x-axis and beta axis that is 45 degree from y-axis. Now I cut in z alpha plane, I cut in z beta plane. Now in that sense, can we calculate the surface area? This was given as an assignment. Anyway, we will proceed on that. But what is the idea? Now I'm cutting this. Now I'm really cutting this. Now earlier I cut in xz plane and then I cut in YZ plane. Now I cut in Z alpha plane. I cut in Z beta plane. Now what is the length equation? If I cut in XZ plane, I get a circle. That is a curved line. What is the equation of this curved line? I plus dz by dxk into dx. What is the curved line equation? So if I cut in YZ plane, again it will make a curved line. What is the vector equation? That is the length vector in curved line, that is j plus dz by dyk into dy. Take cross product of two vectors, you get the area vector. Now that becomes I plus dz by dxk dx cross product j plus dz by dyk dy. Cross product someone takes, then it becomes dx dy dx dy dz by dx minus I vector plus dx dy dz by dy minus j vector plus dx dy k vector. This full is called area vector. If I cut in alpha axis and beta axis, then it will come as I plus dz by d alpha k. Make sense? Or whatever it is. Okay, I'm not pretty sure about it. Okay, similar to that, can we calculate the area vector through that fundamental? Okay, The point here, if I take any point P here, I cut it in Z alpha plane, where alpha is a axis that is 45 degree from X axis, and then I cut in beta that is 45 degree from Y. But I am free to take any theta degree angle axis. I have taken for easy calculation as 45 degree alpha and beta. Okay, now I have to represent this vector, and then do the cross product. That is the concept of this fundamental is. Now, okay, someone can proceed. Now let's think one way that how I can represent any length vector in Z alpha plane. That is a very big question. How I can represent any vector, any curve. This curve is in xz plane. This curve is in yz plane. This curve is in xz plane, 45 degree. This curve in z alpha plane, where this alpha angle is 45 degree from x-axis. This curve is in yz plane. This curve is in beta z plane. Now consider that there is a, if I cut in alpha z plane, then what is the length of this curve from xy? Consider the sphere is centered at the origin. The concept is sphere, whatever sphere we are taking, that is centered at the origin. Half of the sphere is above the xy plane and half of the sphere is below the xy plane. Top hemisphere is above the xy plane and bottom hemisphere is below the xy plane. So I adjusted like this. In that fashion, I adjusted like this. Top is above the xy plane and hemisphere and below xy plane, and it goes inside, and center of this exactly matching this blue color. Center of this is centered at the origin. Now in that case, if I cut it in Z alpha plane, then it will forms a circle where circle is half the way. What is the circumference of this line? So that we will move toward a fundamental of representing this line through a vector. If this line is in xz plane, then I can represent this line as xi plus zk, because y is 0. If it is in xz plane, then xi plus zk, that is the representation of this vector, or I plus dz by dxk into dx. If it is in yz plane, then yj plus zk, because x is 0. Now in that sense, yj plus zk, y I take out, then it becomes j plus dz by dyk into dy. Why it took like that? If someone remembers, in xy plane, if I want to xy plane, if this is xy plane, I want to represent this curve line in xy plane, then first I represented it through a straight line. Then I proceeded into the curve line. X straight line is xi plus yj. Then to represent the curve line, only y by x is different. Then I took out x and it becomes I plus y by xj into x, or I plus dy by dxj into dx. Similarly, take this, if I take this in xz plane, then this curve equation in vector form will be xi plus zk, or I plus dz by dxk into dx, and this in yz plane will be j plus dz by dy k bracket close into dy. If I take cross product of these two, then it will give me the surface area vector. But if I represent this in z alpha plane and z beta plane, and I get the vector representation of these two and do the cross product, it will again give me the area vector. That should be the concept. Anyway, we will start with the finding what is the length of this line. What is the length of this line? The discussion started from the length only. That is why it is length vector. What is length of this line, curve line, that falls in z alpha plane? From this point to this point, means top hemisphere. If I cut the sphere in z alpha plane, it will form a circle where half of the circle is below the xy plane and half of the circle is above the xy plane. Now, if that is the concept, what is the length of this curve from this point to this point and this point back to this point? So, I'll find only length of the top hemisphere multiplied by 2. What is the length of this curve? If this curve is in xy plane, then the vector representation of this length vector is I plus dz by dx k into dx. Now, if someone try to find the length of this, then magnitude of this vector will give the length, that is 1 square plus dz by dx whole square root dx. X is from minus a to a. Makes sense? That will give. Now, what is z? If z is square root of a square minus x square minus y square, that is z for the sphere. Now, here in xz plane y is 0. Now, it is z equal to square root of a square minus x square. Now, the magnitude of this length vector is 1 square plus dz by dx whole square root into dx. Now, in that sense, dz by dx, z equal to square root of a square minus x square. dz by dx is minus x by square root of a square minus x square. 1 plus dz by dx whole square is x square by a square minus x square root. If someone settle down, it becomes a by square root of a square minus x square root dx. That becomes a, I can keep outside, integration from minus a to a 1 by square root of a square minus x square dx. Integration of a by square root of a square minus x square is sine inverse x by a. Sine inverse x by a, where x is minus a to a. Sine inverse minus 1 minus sine inverse 1, that is minus pi by, I'm sorry, sine inverse 1 minus sine inverse minus 1, pi by 2 plus pi by 2, pi into a, pi a. So pi a is the length of this curve. It falls in xy plane. What about if it falls in alpha z plane? If it falls in xz plane? What about the curve length when it falls in alpha z plane? If it falls in alpha z plane, then what is the equation of this vector? Now this vector is xi plus yj. If someone remember, to find the length of a curve, to find the, consider this is xy plane, this is xy plane, this is x-axis, this is y-axis, this is a curve. If this is a curve, then this point is origin and this point is x comma y. What is the length of this curve? To find the length of the curve, we connected x comma y and origin through a straight line. So that pseudo multivariable calculus, we have to start anything with a simplest case. And there we found the vector representation of this straight line is xi plus yj, or I plus dy by I plus y by xj into x, or I plus dy by dxj into dx. This is called vector representation of a curved line in xy plane, where the point is x comma y. What about if it is in xyz? Now this is alpha z plane. If it is alpha z plane, I cut the sphere. If I had a big sphere, I cut. If I had a big sphere, I cut it into z alpha plane and z beta plane. If I cut into z alpha plane, it brings a circle out there. It brings a alpha z alpha circle and z beta circle. Now I'm trying to find again length of this circle from in the top hemisphere. What is the length vector for this? I take any point here, p vector, then p vector is xi plus yj plus zk, where all three are there. Now, in that sense, I consider the magnitude of this xi plus yj plus zk will give me the length of the vector. If I say my z alpha plane curve is represented through a vector and this point is x comma y comma z, because when I cut it, I took a point P on the sphere. That point P is x comma y comma z. That point P is here. And in beta z plane, point P is here. Okay, anyway, or I can say this is z alpha plane. Then here only I rotate it and I say beta z plane. This is point P. This is point P. Now to calculate the length vector in z beta plane, I represent point. I have to represent this curve as a vector. So if I take a point P and connect from the origin as a vector, then this is called line vector, that is xi plus yj plus zk. But problem is y by x is variable and z by x is again variable. So I'll take out x from here. This is $1 trillion proof that how we can represent any curved line in z alpha plane. Now it is xi plus yj plus zk. If it was xy plane, it was xi plus yj. Now here in alpha z plane, it is xi plus yj plus zk. I take out x. Now it becomes I plus y by xj plus z by xk, where z by x is variable, y by x is variable. If I had taken same thing in zx plane, consider zx plane, then y by x was 0 or y was 0 at all. Now anyway, y by x is variable here into x, I plus y by xj plus z by xk bracket close into x, or I plus dy by dxj plus dz by dxk bracket close into dx. This is called length vector of a curve that is in z alpha plane. Makes sense? Now, what is the length of this curve? Length of this curve is 1 square plus dy by dx whole square plus dz by dx whole square root into dx. Okay, where x is from minus a to a, because we are taking x as x-axis, then it will be minus a to a. Okay, people, if someone is taking purely as alpha only, not as x, then it will be directional derivative. Makes sense? Directional derivative means I believe xi, it will be little complex. Directional derivative means we will try to get derivative along the line that is beta alpha axis. Anyway, to simplest case, this would be like that. What is dy by dx? If I see alpha, then it is a line and that is 45 degree from x-axis, and then y equal to x is the equation of the line. So dy by dx on the line y equal to x is 1. So 1 plus dy by dx whole square, 1 square plus 1 square, 2. 2 plus dz by dx whole square. What is z? Z equal to square root of a square minus x square minus y square, where y equal to x. The square root of a square minus 2x square. Dz by dx, it will come as minus 2x minus 2x by square root of a square minus 2x square. Okay, that a square, I'm sorry, it will be 2 minus 2x by square root of a square minus 2x square. Now whole will become 2 plus 4x square by square root by, it is now 1 square plus dy by dx whole square plus dz by dx whole square root dx, x is minus a to a. I believe it is all right. Now, if someone proceed, then it is 2 plus 4x square, that is dz by dx, by a square minus 4x square, a square minus 2x square. If someone settle it down, it becomes 2a square, 2a square minus 4x square. It is 2 here. So 2 multiplied by a minus 2x square will become 2a square minus 4x square plus 4x square by a square minus 2x square. Then in that case, x will go away, 2a square will come out, 2a square. Now square root of 2a square is square root of a. Square root of 2 into a. I believe it is alright. Square root of 2 into a divided by square root of a square minus 2x square. I believe it is again alright. Square root of 2a by square root of a square minus 2x square dx. I can take 2 out. Okay, then square root of 2 will come out. That will go away. A by square root of a a by square root of a by 2 whole square. I believe something like that. Minus x square. I want to leave the x square without any coefficient. If I take a out, then it becomes a square by 2. A by square root of 2 whole square. A by square root of 2 whole square minus x square square root. A by. Now that will become sine inverse x by a by square root of 2. Sine inverse x by a by square root of 2. Now someone can settle it down. Okay, and if you someone settle it down, if x is minus a, then a gone minus, I believe minus a square root of 2 or something like that. Okay, that will be pi by that sine inverse of that square root of 2, whatever it is. Okay, someone can try. I have not tried. But this is the way it should come as pi into a only. Okay, someone can try. Sine inverse x by sine inverse x by a is the integration when it is 1 by square root of a square minus x square. Now instead of a, it is a by square root of 2. Now sine inverse and square root any that is gone. So sine inverse x by a. A is a by square root of 2. A by square root of 2. Then if 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 x is minus a, then it will become, I believe, minus square root of 2. Sine inverse minus square root of 2. Okay, and then sine inverse square root of 2 minus sine inverse square root of 2, something like that. Someone can proceed. Okay, this doesn't look like that very straightforward, but this is the way someone can proceed. We will proceed on this. This is not the end. Then we will get for the z beta plane. Then we will take cross product and we'll come up with the area vector. Okay, now again someone can take it as an assignment and proceed on this, calculating the length vector in z alpha plane. These things are purely research based and it is not available in any of the book. Anyone can try. If someone is really able to crack it, then this will be a new proof at all to calculate the surface area bisecting in any z alpha plane and any z beta plane. Bisecting in zx plane and zy plane, anyway it is not available in any of the book. That is also our version, and that is how to calculate surface area vector and then calculating the magnitude and calculating the integration. We saw that surface area came as 4 pi a square. We'll proceed on this. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.